Okay, so here's the practice worksheet that I'm going to have you guys work on. Up here at the top, it has all the instructions and the steps that we just talked about in the notes. So you can reference those as you're doing these examples. I'm going to do a couple different examples for us to make sure we have all the information that we need. And then it'll be your responsibility to draw the rest of the structures. If you have a printer, you can print this out, but you can also just draw these in your notebook or on a piece of scratch paper. I'm just going to have you take a picture of them and send them to me so that you can get credit for your efforts. So we'll start together working on SO2. SO2 is sulfur dioxide, just to reflect a little bit on our naming practice that we've been doing. The first thing I want to do is think about how many valence electrons I have available to me. So I'm going to look for sulfur and oxygen on the periodic table. They're both in group 6, which means oxygen and sulfur have 6 valence electrons. So I'll do 6. Oh, hello. I want to draw. Why is this being so weird? Well, that was a charming display of operator error. Anyway, so we have 6 valence electrons from sulfur, and then we have, oh gosh, you guys, I'm so bad at using this as a tablet. It's just really sad. 6 from each oxygen, so 2 times 6 means we have 18 valence electrons total. And then we can divide that by 2, which means we have 9 bonding pairs. Okay, so then I'm going to think about which is in the center. Sulfur has a lower electronegativity and it's written first, so it's definitely our central atom. Now I'm going to use 2 of my bonding pairs to stick my oxygens onto my central atom. So I'll subtract 2 off of there. So I have 7 left. My next step is to give a full octet to each of the oxygens. So right now each oxygen thinks it has 2. So I'm going to add 3 more bonding pairs to each one so that it has 8 electrons. 2, 4, 6, 2, 4, 6. So oxygens are happy. We've added 6 bonding pair. So we have 1 bonding pair left. Oops. And now we can look at our central atom and put bonding pairs on our central atom. So we have 1 bonding pair left, so I'm going to pop it on top of sulfur. You could put it on the bottom of sulfur, it doesn't matter. And now I'm just going to make sure everybody's happy. Each oxygen thinks it has 8, and sulfur thinks it has 2, 4, 6. So that's not as happy for sulfur. So now we have to use step 5, which we've talked about before, which is to make a multiple bond, so make a double bond to the central atom using a non-bonding pair from an outer atom. So I'm going to grab this from the oxygen, and I'm going to add that so that the oxygen and the sulfur are sharing it instead of the oxygen keeping it to itself. You might be kind of wondering, you know, why I chose to do that on the left-hand oxygen. And the truth is it doesn't really matter which one you do it on. So we could also draw this as S and then double bonded to this oxygen. And then this oxygen on the left would have 3 non-bonding pair. These are exactly the same thing. And so we call them resonance structures. Okay, resonance structures are Lewis dot structures that look different but are basically the same. Okay, so those are resonance structures. All right. So now I want to go on and do another example. This may be a little bit more complicated. So we're going to look at hydrogen sulfate. So HS041-. And we'll do our normal analysis. We start by figuring out how many valence electrons we have at our disposal. Hydrogen is in the first group. It brings 1 valence electron. Okay, can you not? And then sulfur brings 6. And then oxygen brings 6, but there's 4 oxygens, so 6 times 4. And then we have this little extra electron with that 1 minus charge, so we have to account for him, and so we'll add that one on as well. Okay, so we have 1 plus 6 is 7, plus 24 is 31, plus 1 is 32 valence electrons. And if we divide that by 2, that means we have 16 bonding pair. All right. Now we need to think about what our central atom is going to be. And in this case, our central atom is going to be sulfur, because hydrogen can never be the central atom and oxygen is more electronegative than sulfur. So sulfur is our central atom. So I'm going to put it in the middle. And then I'm going to use my bonding pairs to attach my oxygens. Oh dear. Okay. In a case like this, the oxygen is always going to be attached to the central atom, and hydrogen is going to be attached to the more electronegative element, which is in this case oxygen. So anytime you have hydrogens and oxygens in the same compound, the hydrogens are almost always attached to the oxygen. So I'm just going to put this H on one of the oxygens. Oh, that's a really beautiful line that I just drew. Okay. And it doesn't really matter which oxygen I put it on. I just picked that one because there was room to put it on that one. So far I've used 1, 2, 3, 4, 5 bonding pairs. So I'm going to say minus 5. So I have 9. Nope, that's not math. I have 11 bonding pairs left. So now I'm going to add them to my outside atoms. So hydrogen only needs 2. So hydrogen's already happy because it's got 1 bonding pair. So life is good for hydrogen. I'll just be adding them to my oxygens now. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh dear. Whatever that is, I don't want it. 10. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've added the rest of my bonding pairs. So I have 0 left. Now I need to make sure everybody has a full octet. So sulfur has a full octet because it has 4 bonding pairs stuck to it. Oxygens have full octets, and hydrogen only needs 2. It needs a duet, I suppose you could say. And there was much rejoicing. Okay. Let's look at one more example. Oh, this page is still tiny. That's weird. What could be fun? Let's look at hydrogen phosphate because we can. I mean, what could be better? Let me just make my page a little bit bigger so that I have room to write, because, oh geez, as you've seen, I'm really inept at using this OneNote stylus writing tablet situation. I'll be very happy when I have my whiteboard back. It's low tech and matches my intellectual faculties. Anyway, let's look at this guy down here, lower left corner. That is hydrogen phosphate. So we're going to count up our electrons. Hydrogen has 1 valence electron. Phosphorus has 5. So that brings us to 6. Plus 4 times 6 is 24. So that's 30. So we have 32 electrons. 32 valence electrons. Remember, you got to add that 2 minus those 2 extra little electron dudes right there. So that's how we get 32 valence electrons, 16 bonding pair, and we are off to the races. So phosphorus is going to go in the middle because hydrogen can't be in the middle, and phosphorus is less electronegative than oxygen. So happy little phosphorus in the middle. Now we're going to use some bonding pairs to stick the oxygens on here. Oh, oxygen. And then I have that one little hydrogen, so I'll just throw it over here. And we used 5 bonding pairs to do that. Cool. So we have 11 bonding pairs left. I'm going to add them to my exterior outside atoms first. So then we're going to look at hydrogen. It's the most exterior, but it's already happy because it's got 2. So now we can just worry about our oxygens. So I can add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and everything is good to go. Everybody has a full octet, used all our bonding pairs, looks great. I want to try to find another one with a multiple bond just so we can see another example of that. All right, let's go ahead and do nitric acid as our last example. Nitric acid, HNO3, we have 1 valence electron from the hydrogen, we have 5 valence electrons from the nitrogen, and then we have 3 times 6 from the oxygen, which gives us 24 valence electrons, which is 12 bonding pair. Okay, central atom is going to be nitrogen. Hydrogen can't be the central atom, and oxygen is more electronegative. I'm going to put my exterior oxygens on, and then I can put hydrogen on whichever oxygen I want to. I would not put the hydrogen on the nitrogen. It wants to be on an oxygen. So I've used 4 bonding pairs. I have 8 left. I'm going to add the lone pairs to the exterior atoms so that they have complete octets. So 1, oh gosh, that's not what I meant. 1, 2, 3, 4, 5, 6, 7, 8. That's all my bonding pairs. And the oxygens are in good shape, but nitrogen is not. And so what I need to do is make a double bond. So I'm going to take away bond on an oxygen. I'm going to double bond it so that nitrogen also has 4. You don't have to pick the left-hand oxygen to double bond. You could do this as well. You just don't want to double bond the oxygen that has the hydrogen on it. It just isn't as likely since that oxygen is already kind of sharing between 2 other atoms. So you double bond the oxygens without the hydrogen. Okay, you guys, I'll post a key for this. Good Good luck. Let me know if you have questions.